Question 37. In this question, we are given the outer dimensions of a closed rectangular cardboard box as 8 cm by 10 cm by 12 cm. We are also given that the thickness of each of the side is half centimeter. Now, a closed canister in the shape of a right circular cylinder is to be placed inside the box so that it stands upright when the box rests on one of its side. Okay, this is the condition given, that the box is resting on one of its side and the cylinder is placed in it. Of all such canisters that would fit, what is the outer radius in centimeters of the canister that occupies the maximum volume? So we want a maximum volume of cylindrical canister. Okay, now volume of cylinder is given as pi r square into h. Okay, so we have to remember this. Now there are various possibilities. What are all the possibilities? That I will write it down over here. Okay, now before jumping into the possibilities, we don't need the outer dimensions of the box because the cylinder will be fitted inside the box. So we only need the inner dimensions of the box. So we will be considering, if we subtract a half from each of the side, then the inner dimension of the box becomes 7 into 9 into 11. So these are the inner dimensions of the box, and this will matter when we want to calculate the maximum volume of the cylindrical canister. Okay, so we will be considering this as the inner boundary. These are the inner boundaries of the box. Okay, these are the inner boundaries of the box, and this is actually the top view of the this box, top view of this rectangular solid box. Okay, now let us go case by case. Okay, so case 1 is that 7 is the height and 9 into 11 is the base. Okay, so this is the height, 7 is the height and 9 into 11 is the base. So this is 11 and this is 9. Okay, case 2, we will find out volume for all of this. Okay, volume. Okay, case 2, 9 is the height and 7 into 11 is the base. Okay, once we are done with one of the cases, then I will remove this 7, 9 and 11 figures and we will jump to next case. Okay, case 3, 11 is the height, 11 centimeters. This all values are in centimeters. Okay, 7 centimeter into 9 centimeter into 11 centimeter. So all are in centimeter. And the base is 9 into 7, or let me write 7 into 9 is the base. Okay, so let us go by the first case where 7 is the height and 9 into 11 is the base. So when 9 into 11 is the base, and if I want to draw the top view of the cylinder, it will look something like this. It won't be like this, okay, because it is a right circular cylinder and it is circular in shape. So let me make it so. Now here the maximum radius that we can have, the maximum radius or maximum diameter that we can have, it seems that it will be 11, but it cannot be 11, because if the maximum if the diameter of that cylinder is 11, then what will happen is this will go outside the boundary of it, because this is 9 only. Okay, so the maximum diameter here cannot be 11, it has to be 9. Okay, so the top view of the cylindrical canister will be something like this, where 9 is the diameter of it. So the radius becomes 4.5. Volume of the cylinder becomes pi into r square, which is 4.5, or let me write 9 by 2 square into height is 7. Okay, now here for the second case, the height of the cylinder is the height of the box and the cylinder both. Okay, because cylinder is placed inside the box, is 7 and the base is, okay, 7 is already considered. So height is 9 centimeters and the base are 7 and 11. So here the maximum diameter of the cylinder will be 7 It cannot be 11 again. Okay, it will be the minimum of the two. Okay, so the volume becomes pi into 7 by 2 whole square into 9 to 9. Now, for the third case, last case, we have the height as 11 centimeter. The base is 7 into 9. So here again, the maximum diameter of the cylindrical canister will be corresponding to 7, because it cannot be 9, because if it is 9, then this will stretch to this point will stretch to this, but these 2 points will go outside the box, which is not possible practically. So the maximum diameter in this case will be 7 again, so pi into 7 by 2 whole square into 11. Now we have to compare which of these three are the greatest, is the greatest. So let us compare the first one, or let us compare the last two. Okay, so between this two, pi and this 2 square are common in all of them, so let's cancel all of them. Okay, so here we have 9 square into 7, here we have 7 square into 9, here we have 7 square into 11. So from 7 square into 11 and 7 square into 9, this is definitely greater, this is definitely greater. So this is gone, 7 square into 9, because this is 7 square into 11 and this is 7 square into 9. 11 is greater than 9. Now we have to compare 9 square into 7 and 7 square into 11. So 7 square is 49, and 49 into 11 will be somewhere around 539. Here we have 9 square into 11, which is 81 into 7. Let me write it directly as 567. So this is greater. This one is greater. So for the greatest volume, for the greatest volume of the cylinder, what is the radius that we are getting? The diameter is 9. So the radius is 9 by 2, which is equals to 4.5 centimeter. So our correct answer is option number C. Hope it is clear.